Hi, this is Shoikat Majumdar. Today we will discuss interference and diffraction. Actually, Newton suggested light is like a particle. Newton explained the different phenomena of light, reflection, refraction, with the help of the part particle nature of light. But during the explanation of total internal reflection, the particle nature of light has failed. Then Huygens proposed the wave theory. Wave theory can explain both reflection, refraction, total internal reflection, as well as interference of light. So our outline is today particle nature of light as well as wave nature. Then we will discuss Young's double slit experiment, Huygens principle, then interference and diffraction. Now go to the next slide. Are photons particles or waves? Newton believed that light was particle, as I said you earlier. Light travels in straight line. Particles result in straight shadows. Newton told that when light coming from any source, that means particles are coming from the source, it is falling onto some object and it is reflecting back just like a ball, and it is hitting our cornea, gives us the feeling that the body is like this. This is a ball, this is the phone, this is the pen, this is the bench, everything. So Newton assumed that light is particle in nature. He explained these things, already I have told you. Reflection, refraction is explained properly. But the problem appears when he has gone to explain the total internal reflection. Now, for the photon, we can say is it particles or waves? Now, during the explanation of photoelectric effect, Einstein assumed that light is nothing but quanta. That means quanta of light is coming and it is giving some energy and photoelectric effect happens. If classical physics appears to explain the photoelectric effect, so single violet light wave when falling on some material just like potassium coated or sodium coated materials, it should take alkaline materials, that means sodium potassium coated materials means alkaline materials. It should take 366 days to liberate a single electron. But photoelectric effect is an instantaneous phenomenon. There is no time lag between the incidence of light and liberation of electrons. So classical physics is failed to explain photoelectric effect. Einstein considered that photoelectric effect quantum theory to be applied. So he has considered the quanta of energy is falling onto the material and it is liberating the electrons. Now, wave theory, Huygens proposed the wave theory. Just like suppose a stone is thrown into a pond, it building some just like this waves, and this waves is spreading towards the end of the pond, and at the end it is stopped. Young's double slit experiment, similarly, from the source, the light is propagating along this direction. The coherent source of light, it may be sunlight also from the screens, from the single slit. Now it is coming from these two slits. When they are meeting, they will produce crest and troughs. These are the crest, these are the troughs. When they are meeting in same phase, either crest are meeting or troughs are meeting, then they will produce, when they are meeting in same phase, they will produce bright fringe. That is maxima, interference maxima. When they are meeting in opposite phase, there will be dark fringes. Suppose this one here, this is the maxima, this one is a minima. This maxima, minima are meeting, they are dark. But when the maximas are meeting, this maxima are meeting, then it will be the bright fringes. Another example of wave theory, suppose light waves are coming from this one. If there is a shadow, the light waves are bent. If light waves are bent, this is also we will explain during the diffraction of light. Now, Young's double slit experiment, this is we are discussing, these are as crest and white ones are the turfs. So this crest and turfs, these are when this crest are meeting, crest and turfs. Suppose this one, this is the zone where the bright fringe is produced. That means crests are meeting. This is the bright fringe is produced. When in opposite direction, they are meeting in opposite direction. One is crest, another one is trough. Then the dark fringe is produced. Bright, dark alternatively it is produced. Thomas Young, 1802, he has published this one, Young's double slit experiment. In Young's double slit experiment, conservation of energy is not violated. Young was discouraged by the criticism of his work and gave up his research in optics for other endeavors. He made a major contribution to the Egyptology by deciphering the Rosetta Stone. His theory of color vision is widely cited today. So is his work on elasticity. He made pioneering contributions in studies of sound, tides, human voice, etc. Now this is the Young's double slit experiment. So this is the source of light. It's a monochromatic source of light that is coming from the coherent sources. They are coming from these two slits. They are meeting. This is the detector screen. So we will get bright and dark fringes. Image. This is the image. These are the bright and dark. The patches are here. So these are the nature of the fringe. Now Huygens principle. Huygens principle can easily be explained from the dropping of a stone in a pond. So it is a primary source of disturbance, then it is making the different secondary source of disturbances. So Huygens assumed that light is a form of wave motion rather than stream of particles. Huygens principle is a geometric construction of determining the position of new wave at some point based on the knowledge of the wave front that preceded it. All points on a given wave front are taken as point sources. Remember, point sources. So the production of spherical secondary waves called wavelets. Secondary waves are called wavelets, which propagate in the forward direction with speeds and characteristics of waves in the medium. After some time has elapsed, new positions of the wave front is the surface tangent of the wavelets. Let's go to the next slide. This is the form. This is the propagating along this direction. From this point, so see the velocity of the wave. It is at a distance, at a time delta t, it is moving a distance c delta t. These are the new wave front. Wave front is if you consider a plane enveloping the wavelets. Enveloping the wavelets is the wave front. Now this is the stone that is making the waves in a pond. Inner arc represents part of the spherical wave. It is producing the spherical waves. The points are representative points where wavelets are propagated. These are the representative points. The wavelets are propagated. The new wavefront is tangent at each point of the wavelet. New wavefront is tangent to each point of the wavelet. Here you can draw the tangent. Here you can draw the tangent. Next one. This is the Huygens construction of wavefront. Then again Huygens principle explain that is for diffraction. So we will discuss this diffraction later on.